In this video, I am going to share very important points about a circuit known as slide wire bridge. First of all, let us try to understand what is the construction of this bridge. In this case of bridge, we have a wooden board whose length is greater than 1 meter, and there are three strips, metallic strips of which are fitted on this wooden board. These two strips are of L shape, and another metallic strip is fixed in this position. So I can distinguish these strips by shading these three portions. So this is the basic construction of a slide wire bridge apparatus. Few terminals are provided on these strips. I am showing these terminals by small circles. Let me call these terminals as terminal T1, terminal T2, then T3, T4, T5, and this last one T6 and T7. So these terminals are used for making various connections. And this terminal 6 and terminal 7 have a stretched metallic wire of uniform area of cross section. It is stretched between terminals T6 and T4, and length of this wire is exactly equal to 1 meter, and a meter scale is provided under this wire. So this is the construction of a slide wire bridge. And in order to operate this, what we do, we connect a battery between terminals T6 and T7 so as to supply a constant current through a key, that is one-way key used. And this is high potential battery. And this slide wire bridge is used to determine an unknown resistance. This is the main use of slide wire bridge. And the resistance which is to be found out, that is connected between terminal T5 and terminal T4. Suppose this is the resistance which is to be found. Let me suppose the value of this resistance is X. For this purpose, we connect a known resistance between terminal T1 and T2. Resistance R whose value is known to us. And this terminal T3 is used for connecting a galvanometer. Very sensitive galvanometer is used. The other terminal of galvanometer is connected to a jockey. Jockey means a temporary connection with slide wire bridge can be made through this jockey. I am denoting this jockey by J. So this is the circuit diagram that is needed for determination of an unknown resistance. Now next question is how to determine resistance X by using this circuit diagram that is known as slide wire bridge. For this purpose, what we do, By selecting some resistance, this capital R, we introduce current through this slide wire bridge by switching on this key, and then this jockey J is slided over this stretched wire. When we slide over this wire, then it reaches a position when galvanometer shows zero reading. Galvanometer shows zero reading means no current flows through this portion of wire between T3 and jockey J. When no current flows, then we say Wheatstone bridge is balanced. Then we apply the condition of balanced Wheatstone bridge. Suppose at particular distance from this terminal T6, suppose the distance is L. At this length, this galvanometer shows zero reading, then we note this length L. Now when we are in this position, this whole circuit can be looked upon as a Wheatstone bridge. This circuit diagram is equivalent to the circuit of slide wire bridge. It can be compared with, let us see, this galvanometer is connected between terminal T3 and jockey J. It is here. And between terminal T2 and T1, between T3 and T1, there is resistance R that is known to us. Similarly, X is shown here. What is R1 and what is R2? R1 is resistance of this portion of wire between terminal T6 and jockey. So we can write resistance R1 is resistance of wire starting from terminal T6 and ending at J. Similarly, R2 is representing resistance of rest of the wire, that is starting from J jockey and at terminal T7. So this portion of wire represents resistance R2. This portion of wire has resistance R1. If this length is equal to L centimeter from starting from this to this point, then this rest of the portion will be 100 minus L centimeter, because whole length of the stretched wire is 1 meter or 100 centimeter. Let me suppose that small r is resistance per centimeter length of this stretched wire. Means 1 centimeter portion of this wire represents resistance of small r value. So using this, I can write value of capital R1. Its length is L centimeter. Resistance per centimeter is R. So R1 can be written as L into R. Similarly, R2 can be written as its length multiplied with resistance per unit length or per centimeter. As the galvanometer is showing zero reading, so we can say this Wheatstone bridge is in balanced position. When it is in balanced condition, then according to condition for Wheatstone bridge, I can write ratio of resistance R to resistance X must be equal to resistance R1 to resistance R2. So using this, I can write value of X is equal to R multiplied with R2 upon R1. Now R2 and R1 I have already calculated. R2 has been found to be 100 minus L into small r divided by L into small r, where small r is resistance of slide wire bridge per centimeter of its length. So after simplification, I can write formula for X is equal to capital R 100 minus L divided by L. So this is the relation with the help of which we can calculate the value of unknown resistance. Just we should know the value of resistance capital R and length of the wire at which galvanometer shows 0 reading. That's all.